here we go. So, need those graphing calculators handy. All right. And we're going to enter our data into the graphing calculator. Okay. Now, it wants us to create a scatter plot. We're not going to do that right now. Okay. We're just going to find the equation for the curve of best fit for the data. Okay. So, how are we going to do this? All right. Well, how we entered data into our calculator before when we were going to do like curves of best fit. What did we press? Stat. And then edit. And then we're going to clear out our L1 and L2, and we're going to put our data in L1 and L2. Okay? So, you'll see here we have 3 columns of data. Okay? We're not putting the year in. We're not putting year in as a column. Instead, what we're going to put in the years since 1890. See how it has an X there in that column for the table? That's going to be our L1, and then this will be our L2. So for L1, you're going to do 0, 20, 40, 60, 80, and 100. Okay? And then for the California population, CA, right, California population, we're going to put those numbers in for the L2. So 1.21, whoops. Okay. Now, of course, these are in millions, right? The table at right gives the year in population in millions of California. Okay. So there's our data. What'd you say, second graph?
Second graph.
No, so second graph would not be the same thing here. We have to get the calculator to do the calculation for the curve best fit. So, okay, you're on the right track there. So now what do we press? Once we have the data in, we're going to now press what? Stat again, calc, and then we want because we're talking about exponential curves, right? We're talking about exponential growth here. So we're going to scroll down until we see what command here, do you think? Expreg, EXP reg. That stands for exponential regression. So we're going to hit enter. Ooh, that's weird that did that. Okay. You should have L1 for your X list, L2 for your Y list, or for those of you that don't have this like weird menu, you can just hit enter and it should work. Okay, and you should get this. Okay, I got my A value to be 1.32258255, and my B value to be that. If you got something different, that means you maybe mistyped a number, so go back and check your numbers. Okay, Erica, make sure you're able to do this. You might want to type this in. Okay, if you have your graphing calculator handy, I'd say get it out. Okay, so what's the trouble? Did you get your data typed in?
Yeah.
All right. Mr. Stever's going to come over and take a look at it. Everyone else looking okay so far? Following along okay? You're so behind? Okay, well, we'll wait for like a couple seconds here, get you guys caught up.
I don't know where to go.
Stat, edit.
Cal. Yeah, I know that.
Did you type it in already?
I don't know where to attention.
Oy vey.
Stat.
So stat, edit. Arrow back over. Stat, enter. Okay. So, we have our A and our B given to us. This gives us the equation for our curve of best fit. Okay? So we can go stat edit. Did you type your data in? Then stat calc. We don't want a line of best fit, so we're not going to use linreg. We don't want a quadratic of best fit, so we're not going to use quadreg. We're going to go down until you see exp reg for exponential. And you're going to hit enter until you get to calculate. And then there's your curve information. All right, so if we scroll all the way down to the bottom here on our paper, write your exponential equation round to the hundredths place, which is 2 decimals. So in other words, this becomes 1.32, okay, times 1.03 to the x. Okay? So, well, not right now. We're just coming up with the equation. Now, what then, based off of this, folks, what is our initial value? Okay, 1.32, because A is always our initial value, right? So it's going to be the 1.32. It's the A here. Okay, what is our growth or decay factor here? Well, first of all, it's the B, right? It's the 1.03. Okay, right. Yeah, is it growth or decay, folks? Growth. How can we tell? It's bigger than 1. Exactly right. Okay. What is our change percent? Or in other words, what is our R here? What's our R here, folks? 3%, right? 0.03, that's 3%. Okay? Okay, 3%. If you're not sure about that, remember B is 1 plus R for a growth. Okay? And so we have 1.03 equals 1 plus R. So subtract 1 from both sides. Subtract 1 from both sides, okay, and you get R is 0.03. Okay? 0.03 is your answer there. So 3% is the change. That means in this case, right, we could say that California's population is growing what percent? 3%, right, every year. Okay? Or actually it would be every year. Okay? Yeah. Mm-hmm. Okay, so California's population grows 3% every year, roughly, according to our model. All right, questions on any of that? All right, let's try another one here. Turn your paper over. Okay, and now we're looking at, I don't have the M&Ms, so please don't get your hopes up for M&Ms. I do not have the M&Ms, I'm sorry. Okay, I'm going to try and get some M&Ms maybe tonight, and we can maybe do it tomorrow in class if we have time. So we're just going to do this top one. We'll get to that in a second here. I'll show you what we're going to do next. Okay, so here, these are the closing prices for the NASDAQ stock index at the end of February. Okay, so I think this is like the, I'm not even sure if I could interpret what this means, but it deals with prices of stocks. Interesting. Okay, so we're talking, here's our year, but again, we're not going to use the straight up years. Okay, we're going to use years since 1992, since that's where we're starting. So then what will be our first x value here? 0. And then it's just going to go 1, 2, 3, 4, 5, 6, 7, and 8. Okay? All right. So we filled out the years since 1992. That's going to be in L1. Now we're going to find the exponential regression equation. So you guys go ahead, use your graphing calculator, come up with the exponential regression equation right here. Okay? Type the data in, see if you can do it. All right? If you got left behind for the last problem, try it now, okay? And I'll come around and help you if you get stuck. Okay. Remember, you want to use EXP reg.
So we use the new columns in this?
Nope. Only use, so forget the year column. You can see there's an X here and a Y here. So you're going to want to use that in your L1, that in your L2. We're going to forget about the year, the straight up year, like the raw year kind of thing. Okay, please round to the nearest hundredth too.
Let it ESP, right?
EXP reg. Mm-hmm. Sorry? What EXP reg. Remember, lin reg is for a line of best fit. We want a curve of best fit. Come on, man. Question? Yep, I'll come here.
EXP regression?
Yes.
I think I picked this thing wrong. I don't know. Let me go back to the edit.
Yeah, don't put in the straight up numbers. These numbers. That's your
the R's.
Yeah, don't worry about that. You don't need to have the R's. Okay?
okay.
The R's are they help you to see how good of a fit your curve is to the actual data, but we don't need to worry about that information right now.
Bob? Talking about
Okay. If you get letter B, go ahead and try letter C as well. Try letter C as well. See if you can figure out what the percent increase is each year. And then go ahead and try letter D as well. Try letter D. Use your equation to predict the stock index price. Okay? So, A is 497.13. And that's right. Okay. And then what's your B? I'd say 1.26 because the A was kind of out there, right? Okay. And so then can you figure out what the, according to your equation, what percent increase is there each year? Okay.
oh, there it is.
Yeah, that's close. Good job. You're on the right track. You'll be good now.
Okay, folks, here's what you should have gotten for your equation. I'll zoom in on that maybe. Okay, 497.13 for your A, 1.26 for your B. Okay. Questions on any of that? All right, so then, Lauren, what percent are we increasing every year? 26. Exactly right, okay? Again, remember that your B value is, in this case, since it's a growth, B is 1 plus R. Since our B is 1.26, we can solve for our growth rate by subtracting 1 from both sides here. We get R equals 0.26, which as a percent is 26%. Okay, so there's the answer right there. Okay? Now, the next thing we want to be able to do, again, is use this equation to predict, right? That's the beauty of this. We use past data to help us then predict into the future. Okay? This is called extrapolation. Okay? We extrapolate. So what's that? So, well, what we have right here, Trey, if you think about it, right, what do we have? We have an equation that if we give it a year, it will give us a stock index price. You see what I'm saying? X is like the number of years since 1992, and Y will give us a stock index price. So how many years from 1992 is 2017?
25.
25. Very good. So we're going to put 25 in for X. Don't put 2017 in for X. X is not the years, right? X is the number of years since 1992. So we're going to put in 25. So we'll say Y equals 497.13 times 1.26 to the 25th power. Okay? Please make sure you use parentheses, okay, stuff like that. It's a very large number. 160,595,000.58. Okay? It is, okay? And that is inaccurate, all right? Because the very next year in 2000, we, of course, had the, attack on the World Trade Center, and I think the stock market took a dip. And then things kind of kept as a dip for a little while. Okay, the true answer here, the actual answer, if you want to take a look, all right, there's 2017, all right, and then the average for the NASDAQ index price was 6,235, okay? You can see it reached up to almost 7,000, right, but then the average was 6,235. And so that's still higher, right? It still was growing, right, since 2000, still grew. But it's definitely not 160,595. It's not even that right now, right? That's ridiculously high. Okay, so sometimes exponential models are good. Sometimes they're not so accurate, and that's important to keep in mind. Okay, we're trying to, if you think here, we're trying to measure 17 years beyond where we stopped taking data, right? How could we get a better model here? What could we do to kind of improve our model, perhaps? Well, we won't want to change the numbers because these are the data, right? If we change the numbers, But what could we do here to get a better model, maybe? What could we do to improve our model?
Maybe not have diff mix 17 or diff mix 2 or 3.
Yeah, we could add more data points here. We could look at what 2001 the stock index price was, 2002, 2003, 2004. If we add more data points, we get a more accurate model, okay, more accurate representation, okay? And that's stuff you can like Google and stuff and see it there too, okay?
Yep.
All right, so there's that. All right, again, I'm sorry I don't have the M&M one. I'm hoping I can maybe get a hold of some fun-sized M&Ms tonight. We can maybe try it tomorrow if we have some time in class, okay? So, you don't like M&Ms?
Can't eat them because they're candy.
Any candy? Bummer. That stinks. We'll have to get you something else then.
Well, close.
Don't you like
Yeah.
Skittles there?
No.
Can't do Skittles either. That's candy.
Uh-uh.
They're chewy, not good for braces.
Oh.
Okay.
Yeah.
All right. One.
Brady, you can finally eat food.
Take one and pass it down.
I still eat food with braces.
Take one and pass it
If
down.
you weren't supposed to.
Yeah.
So did my sister. Those people do.
Actually, sorry, did I get one for myself? I did. Thank you, Mr. Senior. Yes.
One, like pretzels, like
The only thing I didn't have was
Mom said how long?
Why did you snack it when you're like 5?
What?
Why did you snack it when you were like younger?
Because my mom, like, works. Yeah, she didn't. You think everything?
Okay, let's take a look at number one. About population growth of Boomtown. Population growth of Boomtown. Okay, so it says here the population growth of Boomtown is shown in the accompanying graph. So here's our graph. We have our years, right? We have the population in thousands, okay, of Boomtown. If the same pattern of population growth continues, what will the population of Boomtown be in the year 2020? Okay, so we have a couple options here. Option one, we could go to our graphing calculators and maybe do like an exponential growth curve there. Okay, we could try that. Okay. Option two, though, is we can maybe look at this and see if we can figure out the pattern here. Okay, so in 1980, what's the population of Boomtown?
2.
It's 2, right? Population is 2. Okay, so 2,000, true. Shh. Okay, what's that, Alessandro? It just doubles, exactly right. Look here, folks. From 2, it goes to 4. 4 goes to 8, and then 8 goes to 16. And so then in 2020, we would expect it to be what? 32,000, right? So the answer is going to be 2 there. Okay, now, real quick, let me just show you. If we had chosen to use our graphing calculators there, all right, so stat, edit, clear out my lists here, type in the data. So I'll do year 0 for 1980, and then 10 for 1990, 20 for 2000, and 30 for 2010. And then I'll type in 2, 4, 8, and then 16. If I do stat calc and then go down to expreg, okay, there would be our little equation right there. Oh, you can barely see it. There it is. 2 times 1.07 to the x. Okay, to the x. And if I'm trying to predict 2020, well, that's 40 years later, so I could put 40 in for x there. I'll do it down here to save on the space. Okay, so I'll do 2 times 1.07 to the 40th. Okay, and notice what I get. When I do 2 times 1.07 to the 40th, I get 29.94, which doesn't match to any of these answers, but which one is 29.94 closest to? To number 2, right, to 32,000. So that one, we would have also gotten the answer that way. It wouldn't have been super precise, but at least it was close enough to be able to identify an answer that way too. Okay? All right. But yeah, Alessandro did it the better way there, okay? Recognizing that there is a pattern here. Seeing that it just doubles every time, that's a much more accurate way to do it. The calculator gives you an estimated, kind of way.
What did you put with the resting power?
40 because 2020. So if you remember here, when I put my x values in my L1, I did years from 1980. So I put in 0, then 10, then 20, 30, 40. And so 2020 is 40 years from 1980. So I put in 40. All right, we'll do one more here. One more here. Number 2, last one. I think we can do it. A box containing 1,000 coins is shaken, and the coins are emptied onto a table. Only the coins that land heads up are returned to the box, and then the process is repeated. This is what we're going to do with M&Ms if I bring them in tomorrow, if I can remember to bring them in. The accompanying table shows the number of trials and the number of coins returned to the box after each trial. Okay, so after start, right, no trials, we have 1,000 coins. Then the box is shaken, they're all dumped out, and any coin that lands heads up goes back in the box. Anything that's tails up goes out of the box. And if it's on its edge, I'd love to see that happen. Okay, anyway, so there's our information there. So we're going to write an exponential regression equation, rounding the calculated values to the nearest 10,000. Okay, so here we go. Stat edit. In L1, I'm going to put 0, 1, 2, 3, 4, and 6. Careful, that's a 6 there. Okay, question. What's that? There's no 2. Oh my gosh, Jackson. Saving the day here. Yes, you're right. It goes 0, 1, 3, 4, 6. So watch your data points there. Thank you, Jackson. I thought I was being clever by noticing the 5, and I completely missed the 2. All right, we'll put in the 1,000. We'll put in the 610, the 220, the 132, the 45. Stat calc, exp reg. Enter, 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 enter. Okay, there's my equation. Can you see it? Sorry, it's light. Bad lighting. Okay, here we go. Y equals, now it says round to the nearest 10,000th. So that means I'm going to do 1018 point. So there's tens, hundreds, thousands, 10,000s. Okay, so I have to do 4 decimal places there. And then times tens, hundreds, thousands, 10,000s. On the table? The table doesn't have it. So that's why we didn't put it to. Yeah, I think so, yes. In this case, yes, we have to use the data that's given to us. Okay, so there's our equation. Is this an exponential growth or exponential decay here? Is it exponential growth or decay? Decay. Yes, it is decay. What indicates that this is decay?
I don't know, I really just guessed.
Okay, you were right. So good guess, Trey. What? 0.5968 because it's less than 1. That's right. Okay, less than 1. Okay. If we want to use but greater than 0, right, also important. Use the equation to predict how many coins we return to the box after the 8th trial. So what would I put, where would I put that 8? In for x, that's right. So 1018.2839 times 0.5968 to the 8th. Okay, so I'll do that here real quick. Okay, and we get about 16.4, or I guess really 16 coins, because you can't really have part of a coin, right? Okay.
You can't have 0.4 coin.
Okay, so since our b value there is, right, since our b value there is like 0.59, shh, listen up here real quick, folks. Since our b value is 0.59, and let's say exponential decay, that means the 0.5968 is equal to 1 minus r. So subtract 1 from both sides. Run out of space here. We get negative r equals negative 0.4032. And divide both sides by negative 1. We get r equals 0.4032. So that means what is our... hold on. We're not going anywhere. Have a seat. What is our decay... Bell hasn't rung yet. What is our decay rate here, folks? Percent, though. Percent. 40%. Okay, now, if we're talking about flipping coins, what should our decay rate be? 50%. So again, the model here, it's showing that we're not getting exactly fair probability, right? We're not getting exactly fair probability, right? Which you know that to be true. If you flip a coin once and you get heads, you don't automatically get tails the next time. To balance it out, you might get heads again, right? But as we go, this R value should get closer and closer to 50% if we do more trials and stuff. Great question, Brady. And the answer is yes. The back is your homework. The back is your homework. What's that? You have a calculator. You can use, I I see what you're saying. Can I get it to you tomorrow, Trey, just because of the timing? Sorry.
Can you grade my homework?
I know it was fine because you were
Wait, what's the
That's okay,
probability
come
that
back
you
to
land all
I
1,000
can.
coins on heads? Find that out.
I can, yes, but I can't do it right now.
Can you grade my homework?
Yes, Brady, if I remember here, I'll put it in. I know, but Brady, when you miss a day or something, it makes it hard for me to get it done at the right time. All right. Kaylee, do you don't have the paper? Okay, let me see here.
Oh, you cracked your screen.
Yeah, it's the screen protector, I'm hoping at least.
That's never good.
Here's Scott's calculator.
Oh, thank you. You can just put that right there. Appreciate it. Okay. Oops, we're lining up, folks, but I guess it's too late for me to have you sit down now, so. Oh well. Have a good day, guys. I'll see you tomorrow. See you tomorrow.
Have a good day, Mr.
You too, John. We'll see you.